This conference will now be recorded.
Okay, good morning, students. Last class we discussed about torque equation of a DC motor. Now, today class we are going to discuss about few more problems on torque equation. So before going to the problems, just I will recall that what are the derivation part we discussed in torque equation. After that, we will go to solve that few problems on torque equation. Right. See, already we know that for DC motor, we are always talking about output energy, that is mechanical energy, right? So here the parameter which is related to the mechanical energy is torque. Now, let me see that what are the steps we are going to derive the torque equation of a DC motor. First of all, we need to find that what is the torque equation for a given pulley. So why? Because the rotor should be in the same of one circular path, right? That is like a pulley. Now when the force is acting on the axis of pulley, then the torque equation is given by T is equal to F into R. So this is the equation given the definition of the torque. So torque definition, nothing but the acting of turning and twisting force on axis is called as torque. So the torque is given by F into R. So this is the initial equation. Now for work done. So how we can write the work done here? What is the work done formula here? How we can write represent work done for this given pulley in terms of force, right? Force into distance, right? So the complete rotation of the circle is nothing but the circumference of the circle. So we can write the force applied on the wheel and its distance traveled. So this is the work done was given by the system. Now you can write in this F is F into 2 pi R. So this is the work done happen on the pulley. Now for power developed. So how much of power is developed on this wheel in this pulley? We can write force into distance traveled into speed, that is n. So this is the equation represented by the power developed on the pulley. So that is armature. Now we can represent this equation in terms of F into R and 2 pi n. So finally you can write this equation torque into angular velocity, right? This is the power developed in the armature. So what is the form of power? This is electrical power or mechanical power? What is the form of this energy? Mechanical energy or electrical energy?
Mechanical energies.
Right. So mechanical energy we can obtain from here, right? Now, according to the equilibrium condition, that is when the input is equal to output. Let me see that according to that condition, what you will get. So here equilibrium condition, we can write mechanical energy is equals to electrical energy. So this is called as energy balance equation at equilibrium condition. It means that there is no losses. We can write like this. So here now we are going to find that armature torque. Now I can represent torque in terms of TA, that is armature torque into omega equals to the electrical energy is available on the armature is given by back EMF into armature current. So this is the energy balanced equation at equilibrium condition. It means that we are not considering the losses here. So just we are giving the input and getting the output. There is no presence of losses. So this will happen at equilibrium condition. Now substitute this equation by using the different formulas. Now here I am taking the n in terms of RPS, revolution per second. Now the same speed, if you want to take in terms of RPM, you have to write n divided by 60. This is in terms of RPM, revolution per minute or rotation per minute. Now from this equation, I am substituting in terms of this formulas, TA into, instead of angular velocity, I can substitute T 2 pi n. So here n is RPS. If you want to take that n is RPM, you have to write divide by 60, right? So I'm taking that n in RPS is equal to, the formula for back EMF is given by P pi n z divided by A. So actually మనకు 60 వస్తుంది, but here I'm taking the n is in RPS. If you take that n is in RPM, you will get P pi nz divided by 60A. Just remember that 60 అనేది ఎప్పుడు వస్తుందంటే RPM కన్సిడర్ చేసుకుంటే 60 అనే నెంబర్ వస్తుంది. If you are considering the speed in RPS, you are not getting the 60 here into IA. Now from this equation, let's take cancel on both sides, n into n will be cancelled. Now that armature torque is equals to 1 divided by 2 pi into, so we have pi into IA. So take pi into IA as common term into PZ by A. So this is the armature torque equation. So armature torque equation is 1 by 2 pi into pi IA into PZ by A. If you simplify this 1 by 2 pi, you will get 0.159 into pi IA into PZ by A. So this is the final equation of armature torque, right? Now we will the next torque is shaft torque. So shaft torque we can append TSH is equals to 9.55 into output divided by n. This is the shaft torque. Now from this these are the two available torques on the DC motor. So ఇక్కడ armature torque అనేది armature లో present అయి ఉంటుంది, and shaft torque which is available on the shaft that is connected between that load and motor. ఓకేనా, ఆ లోడ్ కి మోటార్ మధ్యలో ఒక రాడ్ లాగా కనెక్ట్ చేసి ఉంటాం. సో in that there is availability of torque is called as shaft torque. Now the difference between armature torque and shaft torque we can obtain last torque. So TL is equals to TA minus TSH. So it means that while delivering the torque from armature to the load, there is some certain losses will be happen. ఈ లాసెస్ అనేవి దేని వల్ల జరుగుతాయంటే, ఒకవేళ రాడ్ అనేది సరిగా స్ట్రైట్ గా లేకుండా, అంటే కొంచెం బెండ్ అయినా గానీ లేదా సిలుం పట్టినా గానీ, ఓకేనా, సరిగా ఫ్రిక్షన్ లేకున్నా గానీ, సో అలాంటి లాసెస్ అనేది జరుగుతాయి. సో దట్ ఈస్ కాల్డ్ యాజ్ లాస్ టార్క్ అండ్ ఇట్ ఈస్ గివెన్ బై armature torque minus shaft torque. Now are you clear about the equations, right? Now we are going to solve problems on the torque equation. Okay na? See, all of you take the paper and calculator, then only you can understand the problem. So this is our today topic, that is problems on torque equation. So we are going to solve 3 problems on the torque equation. Then you clear about how we can solve. So these 3 are different problems. Okay now. So if you solve these problems, if you understand these problems, then you will get clear idea about how we can solve the problems on torque equation of a DC motor. Now we'll see that first one, a DC motor takes an armature current of 110 amperes at 480 volts, right? The armature circuit resistance is 0.2 ohms. The machine has 6 poles and the armature is lap connected with 864 conductors. The flux per pole is 0.05 Weber. Calculate the speed, the gross torque developed by the armature. So this is the given equation. In this, we need to solve that what is the speed of the motor and what is the torque available on the armature. So we need to find these 2 parameters. That is, one is speed, and the one is armature torque. So these are the 2 parameters we need to find out. So just observe that carefully. What are the parameters they given? So just I'm writing here. So they given that armature current IA is equals to 110 amperes. So first మీరు వచ్చిన given data రాసుకోండి, then you will get the clear అంటే ఎలా సాల్వ్ చేయాలని మీకు ఐడియా వస్తుంది. And this is the armature current, and the DC motor takes an armature current of 110 amperes or 480 volts. So here the input voltage V is equals to 480 volts. You know, the armature resistance RA is 0.2 ohm. Next, it has the 6 poles and the armature conductors are 864 and flux is 0.05 Weber. So this is the given parameters in our problem. Now we need to find that speed and torque. What is the equation we can use? We can use for finding the speed. ఏ ఈక్వేషన్ యూజ్ చేసుకుని మనం స్పీడ్ కనుక్కోవచ్చు. What is the equation we can use to find the speed? స్పీడ్ కనుక్కోవడానికి ఏ ఈక్వేషన్ యూజ్ చేయొచ్చు, మనం ఏ ఫార్ములా యూజ్ చేయొచ్చు? Right. So we can use the back EMF. Just write that back EMF formula. EB is equals to P pi NZ divided by 60A. So I need to find that speed in RPM. So నేను speed ని RPM తో denote represent చేస్తాను. Now from this equation we need to find that N. So if you want to find the N value, we need to know that what is the values of different parameters. So here what is the we don't know the what is the value of EB, and we know that power number of poles is 6 and the number the flux value is 0.05 and armature current is 864 and 60 and A. So these are all given, but we need to find that what is the value of EB, right? So ఇక్కడ చాలా మంది మీరు కన్ఫ్యూజ్ అయ్యే మీరు ఎక్కడ కన్ఫ్యూజ్ అవుతారంటే, see here a DC motor takes an armature current of 110 amperes. Okay, now armature current అనేది క్లియర్ గా ఇచ్చాబట్టి, and this value represents that 110 amperes is IA at 480 volts. సో ఇక్కడ చాలా మంది కన్ఫ్యూజ్ అవుతారు, అంటే ఇది బ్యాక్ ఈఎంఎఫ్ లేదా ఇన్పుట్ వోల్టేజ్ అని. ఓకేనా, ఒకవేళ బ్యాక్ ఈఎంఎఫ్ అయితే they will mention that. So the armature current of 110 amperes having the back EMF అనే అడుగుతాడు, అంటే ఈ విధంగా ఇస్తాడు. బట్ దే డిడెంట్ గివెన్ అట్ 480 volts. అంటే మనం ఎప్పుడైతే 480 volts అనేది ఇన్పుట్ గా ఇస్తామో, the availability of current at the armature is 110 amperes. So that is the meaning of this sentence. So here the voltage is 480 volts. Now we need to find that EB value. So EB value we know that. So ikkada what is the voltage equation for the motor is the input voltage, that is V is equals to EMF, that is the output voltage, plus IaRa. So from this equation find the EB value. EB is equals to V minus IARA. So here V is already they mentioned here, that is 480 minus IARA is 110 into 0.2. 110 into 0.2. Then find the value of EB. Right. So 458. Now, see, ఇక్కడ మీరు అబ్జర్వ్ చేస్తే we got that value EB is 458, right? 110 into 0.2. 458. సో ఇక్కడ చూస్తే మీకు ఇన్పుట్ వోల్టేజ్ 480 ఉంటే మనకు బ్యాక్ ఈఎంఎఫ్ అనేది 458 ఉంటుంది. ఓకేనా, బాగా గుర్తు పెట్టుకోండి, ఎప్పుడైనా కానీ బ్యాక్ ఈఎంఎఫ్ అనేది సప్లై వోల్టేజ్ కన్నా తక్కువ ఉండాలి. తక్కువ ఉంటేనే అప్పుడు మోటార్ అనేది రన్ అవుతుంది, లేదంటే మోటార్ రన్ కాదు. వై? బికాస్ ద బ్యాక్ ఈఎంఎఫ్ ఈజ్ అపోజెస్ ద సప్లై వోల్టేజ్. సో ఎప్పుడైతే అపోజ్ చేసేది మనకన్నా తక్కువ ఉంటే అప్పుడు మనం బాగా వర్క్ చేస్తాం కదా. సో ఇట్ మీన్స్, సో ఈ విధంగా మీరు గుర్తు పెట్టుకోవచ్చు. అంటే మీకు వచ్చిన ఆన్సర్ కరెక్టా కాదనేది ఎలా టెస్ట్ చేస్తా అంటే, ద బ్యాక్ ఈఎంఎఫ్ ఈజ్ ఆల్వేస్ లెస్ దాన్ ద సప్లై వోల్టేజ్. సో ఇక్కడ సప్లై వోల్టేజ్ 480 వచ్చింది. సో యూ గాట్ దట్ వాల్యూ ఆఫ్ బ్యాక్ ఈఎంఎఫ్ ఈజ్ 458. నౌ from this equation I can write n is equals to 458 into 60 into the value of A. What is the value of A here? 6. Why? Because the given lap connector, right? Divide by remaining 6 into 0.05 into 864. Find the value of speed. What is the speed value here? Oh my God. So it is not right answer. 1187 A motor into speed rotate around. So just find that carefully. Final chain. తప్పమ్మా. సో జాగ్రత్త చూడండి, 458 into 60 into 6. ఓకేనా, సో ఇక్కడ మీరు మళ్ళా చెప్తాను అండి. సో వాల్యూస్ జాగ్రత్త వేసుకోండమ్మా. ఇక్కడ ఈబీ వచ్చేసి 458, రైట్? సో దిస్ ఇస్ ద రైట్ ఆన్సర్, 636. సో యువర్ ఆన్సర్ ఈస్ the answer for speed is n is equals to 636 rpm. This is the right answer. Okay, now we want to find that armature torque. TA is equals to 0.159 into pi IA into PZ by A. Then find the value of armature torque. So here 0.159 and pi value is 0.05. Armature current is 110 into, so here A, P get cancelled because both are same, 6 get cancelled, right? And 864. Then find the value of armature torque. Zero 0.159 into 0.755, right? So the answer for armature torque is, so you can write 756, that is round figure, right? And the units of torque is, so don't forget to mention the units. Why? Because ప్రతి ఒక్క ఫిజికల్ పారామీటర్స్ కి మనం యూనిట్స్ అప్లై చేయాలి. ఓకేనా, స్పీడ్ కి ఆర్పిఎం. సో వాట్ ఇస్ ద యూనిట్స్ ఫర్ టార్క్? రైట్, న్యూటన్ మీటర్. న్యూటన్ మీటర్, రైట్. సో ఆర్ యు క్లియర్ అబౌట్ దిస్ ప్రాబ్లం? సో అర్థమైందా? రైట్, we will solve the second problem. Right. So this is the problem number 2. Just see here what are the parameters they given. So just I'm reading the question now. A 250 volts 4-pole wave wound DC series motor has 782 conductors on its armature. It has armature and series field resistance of 0.75 ohms. The motor takes the current of 40 amperes and it will has the flux per pole is 25 milliweber. Calculate the speed and gross torque available on the motor. So how we can find this value? See, first of all, just note down that what are the parameters they given. So they given that a 250 volt 4-pole wave wound. So here it is clear that the number of poles are 4, right? And A value is 2. And then it has a series motor and has the 782 conductors. So the Z value is 782. Next one is it has the armature and the series field resistance of 0.75. So RA is 0.75. So it is a combination of RA plus RSH. Okay, RS అంటే armature resistance series field రెండు కలిపి 0.75 ఉన్నాయి. Next, the motor takes a current of 40 amperes. That is the input current. We can write IL is equals to 40 amperes and flux is 25 milliweber. So these are the given parameters. So before that, I will tell you, I will draw down a circuit diagram for the DC series motor. So this is the motor and it is the armature winding. So the name itself indicates that when armature winding and field winding both are connected in series, we can call it as DC series motor. So this is the armature winding. I am connecting that series winding in series with armature. That's why it is called as armature DC series motor. Now here we are giving the input voltage that is indicated by V. Okay now. So when we apply the input voltage, there will be a flow of current is called as IL. Line current అంటారు దీన్ని. ఓకేనా, అదే మన జనరేటర్ వచ్చే లోడ్ కరెంట్ అంటారు, ఇక్కడ లైన్ కరెంట్ అంటారు. And this same current will flow through that field winding as well as armature winding. So we can write the armature current and the line current is equals to armature current equals to series current, that is series field current. So all are equal to the 40 amperes. So this is the circuit diagram for the DC series motor. Now we need to find that speed and that is armature torque. Okay, now, so the same procedure what we did in the previous problem. First of all, we need to find that speed by using that back EMF formula. After that, we can find that torque equation, that is torque value, by using the armature torque equation. Now, from this equation, from this data, first I'm going to solve that value of speed. So here, for finding the speed, I'm going to use that the back EMF is equals to P pi NZ divided by 60A. So this is the formula I need to use that for finding a speed value, that is n. Now, if you observe this equation, except back EMF, all parameters that are given in the question. Okay, now we need to find that back EMF formula, back EMF value. So the back EMF value is EB is equals to V minus IARA. What is the value of back EMF here? So here the voltage, the input voltage is 250 volts. So V is 250. Then find the back EMF. So 250 minus IA is 40 amperes into 0.75. Right. So the answer is 230 volts. So now you have to check whether this answer is correct or not. So how we can check means, when compared to that back EMF value is always less than the supply voltage. So మన input voltage 250 volts ఇస్తాం కదా, దానికన్నా EB value అనేది తక్కువ ఉండాలి. So then only your answer is correct. Now let's find that value of speed. So I'm going to find that value of speed by using this formula. So n is equals to EB into 60A divided by P pi Z. Then find the value of n. What is the value of speed? $337. సో ఇక్కడ 0.337. సో ఎప్పుడు సో ఈ మీనింగ్ ఏంటంటే స్పీడ్ అనేది తక్కువ అని. ఇక మీకు 0.337 ఎందుకు వచ్చిందంటే, యు ఆర్ నాట్ మెన్షన్. సో ఇక్కడ మీకు పై అనేది 25 మిల్లీ వెబర్ వచ్చింది. సో మిల్లీ వెబర్ యూ కెన్ రైట్ 25 into 10 power minus 3. ఓకేనా, అది మీరు వేసుకోలేదు కాబట్టి ఇక్కడ 0.337 వచ్చింది. సో ద ఆన్సర్ ఫర్ దిస్ స్పీడ్ ఈస్ 337 RPM. సో దిస్ ఇస్ ద ఆన్సర్. సో జాగ్రత్తగా చూసుకోండి, కొన్నిసార్లు ఫ్లక్స్ అనేది మిల్లీ వెబర్స్ లో ఇస్తారు. సో యూ హ్యావ్ టు రైట్ దిస్ వాల్యూ ఈస్ 25 into 10 power minus 3. Okay, now, so if you substitute like this means you will get that 337 RPM. So ఇక్కడ 405 ఇచ్చారు ఆన్సర్ అయితే కరెక్ట్ కానీ బట్ దే డిడెంట్ మెన్షన్ హియర్ అంటే 10 పవర్ మైనస్ 3 కన్సిడర్ చేసుకోలేదు కాబట్టి మీకు ఈ విధంగా వచ్చింది ఓకేనా సో ద ఆన్సర్ ఫర్ స్పీడ్ ఈస్ 337 RPM. Have you all got this answer? So now we are going to find that armature torque. So sometimes we can call as gross torque available on the armature. So armature torque ananachu leda gross torque ananachu. So don't confuse that. Now the armature torque is given by 0.159 here pi a, right? So here flux is 25 into 10 power minus 3. And armature current is 40 amperes into the number of poles 4, number of armature conductors how much 782 divided by 2. So what is the value of armature torque? So 407 you did the mistake 559 కాదండి సో జాగ్రత్త ఇక్కడ నేను బ్రాకెట్ వేసాను కదా సో ఆ విధంగా బ్రాకెట్ వేసి మీరు సాల్వ్ చేయాలి ఓకేనా సో మీకు ఆల్రెడీ మ్యాథమెటిక్స్ లో ఆప్టిట్యూడ్ లో బోర్డ్ మాస్ అనే ఒక కాన్సెప్ట్ వస్తుంది సో దాని ప్రకారం మీరు చేయాలి ఓకేనా బ్రాకెట్ లో ఉండే సపరేట్ చేసుకోవాలి తర్వాత బయట సపరేట్ చేసుకోవాలి అప్పుడే మీకు వాల్యూ వస్తుంది సో ద ఆన్సర్ ఈస్ 248.6 దిస్ ఇస్ ద రైట్ ఆన్సర్ and its unit is Newton meter. So this is the way of finding that values for DC series అంటే DC series కానీ DC motor DC shunt కానీ so you can solve the problems like this. Now we are going to solve the third problem. It is quite different these last two problems అంటే third problem వచ్చేసి ఇంత ముందు చేసిన two problems కొంచెం డిఫరెంట్ ఉంటుంది సో అది ఎలా చూపిస్తాను చూడండి. So first of all, just I am going to write that torque equation again. Armature torque is equal to 0.159 into pi Ia into Pz by A. So this is the general actual formula for armature torque, right? Now in this equation, this entire term is constant. The number of poles, armature, parallel paths, conductors are constant. So it is not variable. The only variable parameters are flux and Ia. Now from this relation, I can write the armature torque is directly proportional to that pi Ia. Right? So you can write the relation between the armature torque and flux armature current like this. Now you need to know that what is the relation for DC shunt motor as well as DC series motor. Now I am going to write that for DC shunt motor. For DC shunt motor, the flux is constant. So flux is constant. Okay, now we can write TA is directly proportional to that Ia. Okay, now so that this is the reason that DC shunt motor we called as constant speed motor. Okay, మీకు ఏదైనా కాంపిటేటివ్ ఎగ్జామ్ లో అడగచ్చు లేదా Slip test now you can get that question. Which one of the following motors are constant motor? So the constant speed motor is DC shunt motor. Now we will see the same relation for DC series. For DC series, the pi is equals to IA. Okay, now from this I can write the relation armature torque is directly proportional to that IA square. ఓకేనా. సో ఇక్కడ దీని యొక్క మీనింగ్ ఏంటంటే DC సిరీస్ మోటార్ ఎప్పుడు స్టార్ట్ చేసే ముందు ఎక్కువ కరెంట్ తీసుకుంటుంది అన్నమాట. మనం ఇచ్చేదానికి స్క్వేర్ ఇప్పుడు 10 ఆంపియర్స్ ఇస్తే అది 100 ఆంపియర్స్ కి కన్వర్ట్ అవుతుంది. ఓకేనా. సో దిస్ ఇస్ ద రీజన్ ద DC సిరీస్ మోటార్ ఈస్ ఆల్వేస్ రన్ అట్ లోడ్ కనెక్టర్. అంటే DC సిరీస్ మోటార్ ఎప్పుడు లోడ్ లేకుండా ఆన్ చేయకూడదు, లోడ్ కనెక్ట్ చేసిన తర్వాతనే ఆన్ చేయాలి. ఎందుకంటే DC సిరీస్ మోటార్ స్టార్ట్ అయ్యేటప్పుడు ఎక్కువ కరెంట్ తీసుకుంటుంది. సో ఎక్కువ కరెంట్ తీసుకోవడం వల్ల ఏమవుతుంటే ఇట్ విల్ రొటేట్ అట్ హై డేంజరస్ స్పీడ్. ఒకవేళ మీరు లోడ్ కనుక కనెక్ట్ చేయకుండా మీరు DC సిరీస్ మోటార్ ఆన్ చేస్తే ఇట్ విల్ రొటేట్ అట్ హై డేంజరస్ స్పీడ్ అండ్ ఇట్ మేక్స్ టు ద డ్యామేజ్ ఆఫ్ మోటార్. ఓకేనా. అందుకనే ఈ రెండు పాయింట్ గుర్తుపెట్టుకోండి. విచ్ వన్ ఆఫ్ ద కాన్స్టెంట్ స్పీడ్ మోటార్ దట్ ఈస్ DC సిరీస్ మోటార్, సారీ DC షంట్ మోటార్. ఇంకోటి విచ్ మోటార్ షుడ్ నాట్ స్టార్ట్ వితౌట్ లోడ్. Okay, now that is DC series motor. Now based on this relation we are going to solve one problem. Right, so this is our problem. Just note, just read that a 230 volts DC shunt motor runs at 500 rpm and when the armature current is 50 amperes, calculate the speed if the torque is double given that armature resistance is 0.2 ohm. Okay, now here they given that two conditions. What is the two conditions means a 230 volts DC shunt motor runs at 500 rpm when the armature current is 50 amperes. Calculate the speed if the torque is doubled given that armature resistance is 0.2 ohm. Now from this relation, from this question we can solve this problem. So here they mentioned that two conditions. The armature, so ikkada vachesi manaku DC shunt motor kabatti the armature torque is directly proportional to that armature current IA1. So this is the relation in condition 1 and TA2 is directly proportional to IA2. Okay, so these are the two relations they given here. Now from this relation we can write that TA1 divided by TA2 is equals to IA1 divided by IA2. Okay, from ఈ రిలేషన్ నుంచి మనం ఈ విధంగా రాసుకోవచ్చు. సో సిమిలర్లీ TA2 divided by TA1 equals to IA2 divided by IA1. So this is the relation between that armature current and torque. Now we need to find that what is the armature torque when the torque is doubled. Okay, na. So ఇక్కడ మీకు ఏమి ఇచ్చారు, కండిషన్ ఇచ్చాడు. Calculate the speed if the torque is doubled. Okay, na. So torque is doubled అంటే TA1 ఇనిషియల్ కండిషన్ లో TA1 ఉంటుంది, సెకండ్ కండిషన్ లో ఏమవుతుందంటే TA2 ఈక్వల్స్ టు 2TA1 అంటే డబుల్ అవుతుంది అన్నమాట. సో జస్ట్ సబ్స్టిట్యూట్ దిస్ వాల్యూ హియర్. సో యూ విల్ గెట్ 2TA1 divided by TA1 equals to IA2 divided by what is the armature current at initial condition 50 amperes. Now from this what is the value of IA2? IA2 value em vastundi? What is the value of IA2? So when the TA1 get cancelled, so this 2 will get cancelled, then you have 2 equals to IA2 divided by 50. So IA2 equals to 100. So just remember this one. ఓకేనా. సో ఇప్పుడు మనకు ఇప్పుడు చూడండి, we have the values IA1 is equals to 50 amperes, IA2 equals to 100 amperes. Okay, now, so this is the values we got when the torque is doubled. Now what we need to find that, calculate the speed if the torque is double. So we need to find that speed. So from this for this speed we have the relation n2 divided by n1 equals to EB2 divided by EB1. Okay, so ఇక్కడ మనకు టూ రిలేషన్ తీసుకుంటాను. Torque is direct, armature torque is directly proportional to that armature current, and back EMF is directly proportional to that speed. Now from this relation we can represent, we can form this equation like this. Okay, now here we need to find that N2 value. So already they given the N1 value is 500 RPM. Now EB2 divided by EB1. Now how we can find these two values? How we can find EB2 and EB1? ఏ ఫార్ములా యూజ్ చేసుకొని మనం EB2 ని EB1 కనుక్కోవచ్చు. Which formula we can use for finding that EB1 and EB2? ఏ ఫార్ములా యూజ్ చేయండి? జస్ట్ థింక్, if I will give two choice, EMF ఈక్వేషన్ యూజ్ చేస్తారా, వోల్టేజ్ ఈక్వేషన్ యూజ్ చేస్తారా? Right, super. So this is the equation we can use. So here first I am going to write that EB1. So EB1 is equals to V minus IA1 RA. సో ఇక్కడ మైనస్ వస్తుందండి. సో ఎందుకంటే మామూలుగా ఫార్ములా ఏంది, V is equals to EB plus IARA. ఓకేనా, బాగా జాగ్రత్తగా గుర్తుపెట్టుకోండి. సో జస్ట్ రిమెంబర్ దట్ ఐఎమ్ గోయింగ్ టు రైట్ దట్ టూ వోల్టేజ్ ఈక్వేషన్. సో V is equals to EB plus IARA. This is the voltage equation for DC motor. Okay, now next EG equals to V plus IARA. This is the equation for DC generator. Okay, now so just remember that. Now we need to find that EB1. So EB1 is equals to V minus IA1 RA. So here V is 230 volts minus the armature current at initial condition is 50 into armature resistance is 0.2. Then what is the value of EB1? $210, right? So the EB1 value is 210. Next EB2. Find the EB2 value. EB2 equals to V minus IA2 RA. $200 minus 100 into 0.2. So its value is, what is the value here? సో సారీ, ఇక్కడ వచ్చేసి మనకు 220 ఇచ్చారు. 220 వాల్యూ ఇన్పుట్ వోల్టేజ్. 220 minus 100 into 0.2. 220 minus 100 into 0.2. So it is 220. 220 minus 100 into 0.2, you will get 200. So ఇక్కడ V వచ్చేసి 220 ఏమో. So the supply voltage is 220. 220 minus 50 into 0.2, you will get 210. Similarly 220 minus 100 into 0.2, you will get 200. Okay, now by using this relation, we need to find that speed. That is second condition. So N2 divided by N1 is equals to EB2 divided by EB1. Okay, now we need to find that N2 value. So N2 is equals to N1. What is the value of N1 here? 500. 500 into the value of EB2 is, what is the value of EB2? 200 divided by 210. Find the value of N2. $476, right? 476 RPM. This is the answer for N2. So just observe that the back EMF is directly proportional to the speed, right? So it means that when back EMF increases, speed also increases. So మనకి EB1 ఎంత వచ్చింది? 210 వచ్చింది. So the EB1 is 220 and in this condition the N1 is 500 RPM. Second case లో EB2 ఏమొచ్చింది? 200. So it means that the back EMF is reduced to 10 అంటే 10 నుంచి 200 కి reduce అయింది. సో ఆటోమేటిక్ గా స్పీడ్ కూడా రెడ్యూస్ అవుతుంది, దట్ ఈస్ టు 476. సో ఈ విధంగా మీరు చెక్ చేసుకోవచ్చు అంటే మనకు వచ్చిన ఆన్సర్ కరెక్టా కాదా. ఓకేనా, రైట్. సో ఓకే స్టూడెంట్స్, దిస్ ఇస్ అబౌట్ ప్రాబ్లమ్స్ బేస్డ్ ఆన్ ద టార్క్ ఈక్వేషన్. Now tomorrow class we are going to discuss about what are the different types of DC motor. Okay, now already man types of DC generator chesam kada, the same thing we are going to know that what are the different types of DC motor we will discuss in tomorrow class. Okay, okay students, it is time over. Now I go to end this class now. So మీకు ఈ PPT ఈవినింగ్ సెండ్ చేస్తాను, అంటే గూగుల్ క్లాస్ రూమ్ లో అప్లోడ్ చేస్తాను, దెన్ ప్రాక్టీస్ దట్. ఓకేనా, right. So I'm going to end this class now. Thank you.